you are doing fine. Okay, perfect, perfect. Cool. So I think since it's a 1 hour session, so I would really would also want to get started because we've already have like 4 minutes passed by. So hello everyone. Do we get this recording? Yeah, I'll try to answer a lot of there would be it'll be questions, but yes, I think you should be having, and I think it should be also available in the uh, Ivy's YouTube channel, so you should be able to like follow it from there. So no worries. Okay. Okay. So first of all, again, thank you everyone to join this particular session. So as you know, this session is about the usage of AI in a lot of different business cases, and specifically what we will try to discover and discuss how does recommendation systems work from a perspective of AI, right? And you will be able to kind of relate it very easily because I'm sure a lot of you guys use like an app like Amazon or Facebook or even like the apps of Mintra and so on and so forth, right? So it would be I'm sure it would be a very interesting session for you guys. I'm also sure that a lot of you guys might already have some idea about how machine learning models work. We'll not be able to like cover everything. I know there would be a lot of things which would be new for you for some of you, but I'll try to keep it as precise so that most of you guys can understand what we are trying to talk about right here. So, okay, so with that, let me try to share my screen, guys, and we can get started. So, just let me know if my screen is visible. It should be visible, yeah? To all of you, can you guys see it? Everyone, can you guys see it? I hope to all. Perfect, perfect. Okay, okay, okay. So, how many of you guys know about recommendation systems? Let me start with that. And what do you know? Like, you can talk about from a consumer point of view. You can even talk about from an like someone who is making it. So, any ideas like what recommendation system says or what they are used in a real life case? Anyone? Have you got any recommendations in your recent purchases? So you guys, I hope get do shopping on Amazon or something like I'm sure we all do. So do you see something like people like you have also bought this, or I'm sure like a lot of you guys also might be using watching Netflix or Prime or whatnot. It might also tell you that based on your watch history or people like you have also watched this, so it gives you certain recommendations, right? So and when you open the app, you do not get a list of 1,000 products among the because Amazon or let's say Netflix or any of these, they have a pelotra of, I would say, items or whatever right they can use. But it's not that everything is there, and what they are showing you is very personalized and also very prioritized, right? So there are a lot of items which you will be feeling that okay, how does it know and all of that, and that's what we'll try to cover today a bit, like how does this work. And we'll try to share these materials. I'll try to share it with the team so that you guys also can have an access to it. But the idea is like to just to understand and appreciate like how these models work at the back end. Um, in terms of a bit of the functional, we'll not go into the too much details because again, uh, the time might not have a justice to it. But then we'll try to at least understand the essence of how these models work, right? And it's a pretty these are pretty interesting models because of the fact that a lot of these models are actually being used, and we as consumers, let's say when we are using any of these apps, we actually use them. We actually use these models in a way that we are the consumers of this model, right? So now, if an as aspiring data scientist or someone who is interested into data science or ML, I'm pretty sure that you would be interested to know how these models work in the backend, right? So that's what we'll try to cover. Uh, so yes, so it's about recognizing the patterns and everything, right? So first we'll start with the with a gentle introduction of what recommendation systems is, and I think I've been talking about for some time now that what recommendation systems is, and I'm sure you guys have all kind of seen it in your real life scenarios. For example. Just to call out certain organizations, at least in India, like you have Amazon, Flipkart, YouTube, LinkedIn, Myntra, like Facebook. And if you see, one of the common things that is common among all these ones is basically they all provide us with recommendations, right? So I know I should be replacing uh, with Insta. But then yes, most of the in terms of the latest I would say social media accounts. But then a very common thing as well is that all of these are providing us with a certain amount of recommendations, and a lot of our purchases can be attributed to these recommendations, right? Be it in terms of let's say a video that we watch, or let's say a product that we watch. And a lot of these you will see that if you have seen something in a particular social media app, that kind of recommendation will come into Amazon or Flipkart. So we'll never know that how it is all related, right? So that's what we'll try to cover today. So from an business sense, this is very important because a lot of things now, a lot of the shopping experience happens digitally, right? So we all, I think, know that. So it's all digital, right? And since we are into the digital world where there's a lot of scope of influencing the consumer decision, and even not like Amazon actually coming and talking to you, or someone trying to selling it on purpose. It's a very subtle way of also promoting products, right? And that's why it's very interesting and important for business, right? So for example, this is an I know it's a for example, if you purchase a phone, you will see that customers who bought an item who also bought this, right? So similar, something like that. You'll always see that yes, there is always like these recommendations popping up in your screen, right? So you guys, everyone is kind of familiar to this concept as consumers, at least. I'm sure i'm sure everyone is at least familiar with the concept of like recommendations. Yeah. And how many of you guys have I would say purchase something because of recommendations? Any time? Did you buy something because you were recommended something? Yeah. So and that's where I would say like this becomes very interesting for the companies, even because of the fact that uh, it's so personalized, and it can, and imagine, let's say each one of us is like a potential customer to these big giants, and when you are influencing the customer cohorts in such a large scale, uh, you have a scope of earning a lot, right? Because of this particular uh, technique, right? So let's try to take a step back and try to understand what is the technology that goes behind. So I would say the crux or the inception of recommendation was brought by Netflix, and we'll try to talk about it. But in short, like what it is, so it's basically a class of information filtering system, right? So the idea is that instead of overloading you with thousands of products, or millions of products, even though they have a catalog for that. What Amazon wants to show you, or any of these, I would say, apps wants to show you the product which you're most likely to buy based on your, based on the data that you have given to the model, and it will, and so that you can ideally, you want to maximize, the likelihood of purchasing. So it's all about leveraging the customer's preferences and your history, and and overall Netflix was the one which basically brought recommendation systems as a key concept right into the productions. When I say production, like actually companies using it, because a lot of times there are a lot of ideas which are just like developed, but very few of the ideas actually get into production, right? For example, this recommendation system, or now there is a craze of Gen AI. So we are talking about creatives, or we are talking about codes being written by AI agents, and there's also something about like agents learning with each other and all of that. So that's all right now that we are understanding and experiencing, but it doesn't mean that everything that is being developed gets gets like a or sees a sun. A lot of times that gets filtered on. Recommendation systems was one of the initial models which got and machine learning models which got popularized, and it was basically done by Netflix. And if you will see that these numbers, right, 75% of movies are from recommendations. 38% of Google's click through are through also through recommendations. From Amazon also, it's almost 35% of sales which is coming from recommendations. So which is a huge like almost one third of the number which is coming from actually like recommendations, right? So for the business, it's a very important thing, and it's not like about doing some kind of studying every consumer and doing it. It's just about deploying a model which is able to decipher these patterns in the consumers, like the products that the consumer has purchased, and what kind of product the consumer is likely to purchase, right? So now, very quickly put, and once we I go through through the content first. We'll also try to do an hands-on, so don't worry. And then I'll try to answer all your questions. So we'll try to take a break between the hands-on and this, and I will also try to answer your questions, right? But just to talk about, there are two major approaches to recommendation systems, right? So one is what we define as collaborative filtering, and the other is something what we define as a content filtering, right? Now both of these are like models of their own. So it's not that every recommender is basically using only content or only collaborative, or both content and collaborative. The good recommenders of the world are obviously using both of them, like both content and collaborative. But a lot of models also do use only content or only collaborative, right? So it's basically the universe, and we will also see like how we can basically uh
Excuse me, sir.
yeah.
Sir, can you please go a bit slow?
Sure, I will. uh I will. I am just cognizant of the time as well, because we have a lot to cover. But anyways, I will try to be a bit slow, right? Okay. So what I was referring here is in terms of the two approaches, right? The two approaches to the recommendation system, which is the collaborative and the content. Okay. Now, both of these are very independent models. I'll not go into the details of finite details of it. But as I was mentioning, that these models are very powerful in terms of recommending things, right? So just to take a look of what collaborative is, a very simply, I'll give you an example. Maybe I will try to start with a simple example of what collaborative does. So imagine, let's say there are four users, right? And these users are Annie, Bob, Carl, and Dan. Okay. Now each of these four users have watched these four movies, right? Now, so Amy has watched Men in Black and has given an rating of 5. Similarly, watched Apollo 13, given a rating of 4, and so on and so forth, right? Similarly, Bob has also watched Men in Black, has also watched Top Gun, given a rating. So these are just the ratings, right? And what you want to do is that, what, let's say you want to suggest Carl that he watches Men in Black, right? And why we would watch, uh, why you would watch, recommend Carl to watch Men in Black? Because of the fact that both, if you see in terms of the preferences, both Amy and Carl have similar preferences, right? So they have both watched Apollo 13. They have both kind of rated it high. They have both watched Top Gun, and they have also kind of ranked it high. And similarly, they have also watched Terminator, and they have kind of ranked it high. So definitely, based on their similar preferences, it is very much likely that if Netflix recommends Men in Black to Carl, it will be watched, right? So in terms of collaborative filtering, what we are generally trying to look is basically the behaviors with similar users, right? So let's say if you and your friends have similar behavior, and the products that your friends like and the product that you like, they will be basically recommended to each other, right? I hope you got the concept of collaborative. Does this make sense? Like essentially what is happening? Obviously, there's a lot of depth to it, but does this make sense? Did you get an idea? Because that's one of the key models that gets used, right? The collaborative one, right? Uh, The other one which we are talking about is the content model, right? So in content model, what we are saying is instead uh, of the user's behavior or the user's similarity, it's about your own history that you provide, right? So in content filtering, the entire model is based on the user's historical behavior, right? So here, what we are simply doing is, let's say you have already watched and liked, let's say, Men in Black, and it was, let's say, directed by a certain director. It's a genre of action. It stars Will Smith. So based on this history, right, it will try to recommend also movies of the same director, of the same genre, or of the same actor. Getting my point? And I think you guys have seen this, right? I'm sure this uh, might be very much something relatable, right? Because when you open any of these OTT platforms, so it will tell you that since you have watched this, it's good to also uh, basically watch this again, right? So that's what entirely is content and collaborative filtering. So in content, in short, just to summarize, I think some of you guys are mentioning. Shuyash, this is specifically for you, since you asked. So in short, what content means is that, let's say you have watched certain things, based on that history, it will recommend, right? Does this make sense? And to others, what content is doing? So based on your history of interacting, right? The model is trying to basically recommend you. Okay. In collaborative, what is happening? It's all about the similarity, right? So imagine there are two people who have very similar preferences, and whatever the items is preferred by one user will also be recommended to the other user if they have not used it, right? So that's essentially what these two models are trying to do. Now, go for it if it's still unclear to you guys. The essence, right? We are not going to the details of the mathematics and the equations, but does this make sense? Everyone, was it clear? Did it make sense? Did it give you some understanding of the working behind the models, right? So two major things which is happening in content, it's all based on your behavior, right? So if you are watching, if you are interacting with the machine, it's tracking your behavior, and based on that, it's trying to pick out certain attributes. For example, in movies, it will pick out similar directors, similar actors, similar genres, and try to recommend. In collaborative, it's all about the similarity. If you're watching and if you're liking something, other person is also watching or liking something. Based on that similarity, it will try to recommend something else. Cool. Okay. So now we can use models in isolation, which means I can just go and build a model using only content filtering. Uh, or I can also try to build a model only using collaborative filtering, right? So both of these models are independent. It's not that um, they have to be used in conjunction, but like the best class of models are one which basically uses or combines both of them. That what is something what we define as a hybrid recommender system, right? So it captures the best of both the worlds. So it combines collaborative also, it combines content also. So what we do is generally we can basically give some weights. So which means you can give some weight to content and you can similarly give some weight to collaborative. And the final output that comes is basically a combination of these two recommenders, right? So the models which are actually deployed for Netflix or any of these e-commerce giants generally use the combination of both the models, right? So if you see the example that I'm referring here, so let's say through content, the movie Terminator was recommended, right? And let's say if there are these two similar users, let's say Amy and Carl again, and if they have liked the same genres, so it's Starship Troopers. So in that case, Starship Troopers can be recommended to both Amy and Carl, right? So basically that's how you can use these models, right? Where you can combine uh, these models. Now there is obviously a double click to it, is that how does the model finds the similarity, how does the model goes about and understand that if you have watched this you will be watching something else. So there is something specific which I will mention but not go in detail, is what we define as cosine similarity. So that is what is used for finding the similar product. So you guys can do a bit of research if you want, but then I'll not go into the detail of it. But yes, that is under double click of it. How does the further similarity scoring happens, right? And
Are
within
these concepts from data science?
come again.
Are these concepts from data science or else like ML?
Valid question. These are when we say data science and ML, I think we should be understanding the actual application of these words. So, machine learning and data science is not there something very different, right? Let me make it very clear. When we say machine learning, it's about the entire family of models that we're dealing with. The rules can be different. For example, you can have an MLE versus a data scientist, right? MLE are the ones, or machine learning engineers are the ones who are productionizing the models, and data scientists are generally the ones who are building the models, right? But this particular concept is more about the technique, right? So it fits under machine learning. At the same time, it's a subject of data science as well. Hope I answered your question.
Yes.
Okay, cool, cool. So yes, we do use this, and so do machine learning engineers in the entire frame of things. As I mentioned, machine learning engineers are more towards productionalizing the models and not towards actually building it. Whereas we are more focused upon tuning the models, making sure that the results are good, right? And also sometimes communicating the results to the business. So that's the key role for us. Cool. Does this make sense? Ready for the code walkthrough? I hope you got an idea at the back end, like what's happening.
So can you please explain the project?
Sorry, explain what?
explain the project team.
Project is something that I will explain. I have not started with it. Don't worry. I haven't started with the project. If you're talking about the case, we'll start with it. But any major doubts in terms of the overall concept of content or collaborative? Did it make sense? I hope it did. Okay, so now I will try to introduce you with the project. Uh, so and why I introduced or gave you that overview, because now I think you will be able to understand the code better. So basically, in the next 30 minutes, what we will try to do is basically try to build a model, right? It's a machine learning model, which can recommend things based on the content and the collaborative filtering that we discussed, right? So the data that we will be using is from Amazon. So obviously the product codes are kind of masked, which means we do not have the actual product names, but we have the product codes, right? So codes are like these alphanumeric characters, uh, which and let's say one character represents to one product, right? So yeah, so basically this is what we'll try to do, right? So we'll use the Amazon data, and the idea would be, let's say if I am searching for a new product, what could be the other products that could be recommended to the user, right? Does this make sense, or I can explain it again to everyone? From where we will get this data? The data, I think all the materials, Shreyash, you should get it. Don't worry. We'll try to hand over the materials to you. Okay, so you guys can actually run this code whenever you want. Obviously, you might have some more clarity once you run the code by yourself. Cool. Is the problem statement clear to everyone? Does this make sense? I hope. Yeah. Cool. Let's basically get started. So, to reiterate, Amazon uses different recommendation models, and we use different suggestions to different users. And it is done in a very real-time basis. So, obviously, if you're searching something, it will recommend you in that pretty real time, right? And this type of filtering is what we talked about, is the usage of content and collaborative. And in this project, what we'll try to do is we are going to build a recommendation model which can recommend based on the electronic products of Amazon. So for building this data or this project, we have four kind of attributes. We have the user ID, which is like the ID of the user. Imagine it as a customer ID. So it's obviously a unique ID. We also have a product ID, which is like a unique ID to map to each product. We also have the rating. Basically, the data is at a user ID cross product ID level, along with the rating. So rating is, imagine, let's say if someone has given a rating of 1 to 5. A rating of 5 means higher or highly recommended. A rating of 1 means least recommended. And also we have the time of the rating, right? So these four features that we have. So we'll first try to connect to the data. So I have it in my drive. So I will just quickly get connected to it. Okay, I think it should be good. So yeah, so these are the packages. And how many of you guys are comfortable with Python here? Because there would be few things and that. How many of you guys? know Python or have some knowledge? Or if I reverse the question, for how many of you guys it's completely new? Completely new? I'm new. Okay. So, okay, don't worry. Again, in the we would be using some Python coding because we cannot build a model on pen and paper. But the point is, again, I think we have all modules for structured learning, and you can connect with Ivy for that. But yes, I'll try to explain overall in terms of what are the things that we're using, right? So if you see, these are the certain set of packages. So packages are nothing but things which can help you to accelerate and build the model. For example, I'll give you some examples like NumPy and Pandas. These are the packages available in Python to help you to do data processing, right? Simon, for example, is very good for visualizations because we'll try to do some visualizations, right? So now here I mentioned my file path, right? And what you will do is basically this zip file has multiple CSVs. So basically, what it will do, it will try to read all the CSV one by one, and basically load the data. So if I show you, so this is how the data looks like. DF is basically a data. So I'm sure everyone has seen a data like an Excel data. So you will have rows and columns. Python, you can also have similarly what we define as structured data in pandas. So the head basically shows you the first five rows. So you have the user ID. The user ID represents the customer ID, the product ID, the rating, and the timestamp of the rating, right? So we want to do some quick check. So the info shows how many rows we have, how many columns we have. So we have total of 2.5 lakh rows and four columns, right? Which we discussed: user ID, product ID, rating, and timestamp. We also have the data type, like what are these? Like if it's an integer data or a float. Object simply means it's a string data. So the total number of users is basically 23476, and total number of products is 86,000. So this is the unique number of products and the users in the entire data, right? Whenever we read a data, be it any model that we build, it's generally good to do some sanity checks. For example, we can see if there are any missing values. So is null.sum can show you that if there is a missing value here. So we do not have any missing values here. We can also check if there is any duplicated data. So here, and it's very important because a lot of times you might have duplicated rows, right? Which is not ideal for building a model. And here, if you see, we do not have any duplicated data, right? So whenever you are building model or whenever you are doing any basic checks as well, it's good to do these basic sanity checks, right? Now, if you see, what we're doing is we'll create some visualizations, right? So very simply put is that we are trying to see how many rings are there and what is the average rating, right? So basically, we are trying to create the rating count and the average rating. So you will see uh, these are the ratings by product, right? So how do you interpret this? So basically you can interpret it as, for this product the rating count is 1 and the average rating is 5, right? For this product the rating count is 37 and the average rating is 4.7, right? Similarly, you can check the histogram of the rating. So basically, how the rating is. So if you see, there are a lot of products with a rating of 5 and 4. We also have some products with a rating of 1, but majorly the rating is between 4 to 5, right? So again, just to get an idea of how the data is, how the data looks like, and you can also try build something like a scatter plot, which is like an correlation plot between rating counts and rating. So it's a good way to check like this is basically the number of ratings, and this is my rating, actual rating, which is 1 to 5, and you will see most of the ratings are in 5, and some of the products also have gotten higher rating, right? So the rating count is also high, as well as the rating is also pretty high, right? Again, just to get an sense of the data. And as well, we can see like what are the top 30 products. So here if you see, we are displaying the the or returning 30 items, and we are sorting the entire data frame based on ratings. And if you see, these are the list of all 30 items, basically sorted based on the number of ratings they have. So these are the number of products, 30 products with a certain set of ratings, right? So it's good to see. So basically, if you do not have any history, if you do not have any model to train, you know that what are basically um the most popular products is available, right? So it's always good to get an idea of that, right? Does this make sense till here? A quick sense check. I know a lot of codes might not be clear, especially for people for whom it's new, but in general, does this make sense? Like the basic EDA that we did till here, did you guys follow? We can also visualize this in Power BI, yes, for sure. But a lot of times when you're building the model, you want to use one application only. So that's why we use Python, but definitely, yes, we can also do that. Yeah, cool. So now what we'll try to do is we'll try to build an rule-based recommender model, right? What is a rule-based recommender model? So this will not use any machine learning. What it will do, it will basically recommend based on the popularity, right? So the popularity base simply means that if something is popular, it will be recommended to you, right? So imagine, let's say there is a new fashion trend and everyone is buying that. So the algorithm will also recommend that to you, right? So it's just a rule based, which means it will not be personalized, because it might not use your data to basically recommend it. It will just go and try to recommend things based on popularity, right? So it would be similar to what you will see, that top 10 series in your country today, right? Or top 10 movies in people watching, right? So that is what the popularity is, right? And this is what you will exactly see in Netflix or in any of the recommender models. So what it generally does is that it tries to work on a weighted score formula. It gives a weighted rating, which is basically taking into account two things, or four things in fact. The first is the average rating, right? The second is the number of votes that particular item or movie has achieved. M is the minimum number of votes which is required to be listed among the popular items, and average rating across the entire data set, right? So we can calculate the same thing for our data as well, because we already have the ratings, we already have the number of votes, right? And what we define is we would want to, let's say, uh, get based on the top 95 percentile, right? So M is like the top 95 percentile of the votes that I would want to recommend. So basically everything which is in the top 95 percentile only should be recommended, right? So if you see, the average rating of the entire data set is 3.8, which means if I take the average of all the ratings that I have between 1 to 5, my average of the rating stands at 3.8, right? So here if you see, the minimum number of votes required is at least 9. So at least 9 should be the number of ratings that should be available, right, for product to be listed. So what we will do now is we simply try to filter all the ratings which is greater than M. M is basically 9, right? And obviously we'll not use the not null. And this would be the entire list of products, right, which are qualified. So which means if you see this is like the first top five products. They have a rating kind of 37, 22, 12, 10, 9, and this is like their average rating. This is simply the count of ratings. This is like their average rating. So basically we're taking into account two things. Very simply put, one is the number of people who have rated it. So let's say that the product is very good, but let's say only very few people have rated it, right? So you don't want to buy such products as well. So when you try to go and buy something, so you try to see both the things, right? Not just that if the rating is good or not, but how many people have actually rated. Because let's say if it has rated by only two people or three people, you might not know if it is genuine, right, or not. It just might be some fake profiles rating it. So you try to look at both the things, both like how many people have rated it, but at the same time, what is the final rating, right? So that's basically the overall number of items that is there. And not what we are doing is we are basically applying the formula of the rating, right, that we talked about. And based on that we can see like how many products that gets recommended. So let's say these are the top 10 products, right, based on the weighted rating score. This weighted rating is simply formula that we talked here, right, which is the number of votes by number of votes plus average rating into the average rating plus minimum number of votes by the number of votes plus the average rating into average rating across the entire data set. C is like it's not based by item, it is like the overall average, right? Not just based by any item. And now you might ask me to devise this formula. So this is like based on the popular movies. So it's defined by the big companies for basically suggesting items based on popularity. So if you see in our entire list of things, these are the top 10 products, right, based on the highest weighted rating, right? So if if you try to visualize something, so here what we are doing is we are trying to just create a simple bar plot of these 10 products, right? And along with their the count, and you will see that, yeah, so these are the top set of products which are highly popular, right? Again, there is no personalization to it because this is just working on the principle of popular rating, right? So you can do the same thing with average rating. So this is based on count. You can create the same plot with average rating. So you'll see the average rating is quite similar for all these products in the crux of 5. And similarly, you can have the weighted rating. This will have some sort of difference because obviously we have again very marginal, starting from 4.5 to maybe nearing towards 4, right? But the crux of this entire first solution that we discussed was mostly that it's not based on any machine learning, more of rule based, right, based on a logic that we defined. And it is not personalized, which means everyone will be getting the same recommendation. So everyone who is logging the app, everyone will get the same recommendation. Why? Because this is just based on the average rating. So no user data is being used, right? And that is what you would not want ideally, right? You would want something to be basically which can be personalized, right, and which can be easily uh, accessible and easily relatable, right? So that is where the machine learning thing comes, because in that case uh, it can basically use the user history and try to build the model, right? Does this make sense to everyone till here? I know we covered in a small of time. How will you get to know this formula? How can we compute this? So as I said, Sam, this formula is something which was devised by the likes of Netflix. So you can so again, this is a formula which you can change, right? It's not casted in stone that we need to use this formula, but generally the idea is to weight it. I hope you got the logic, right? So the idea of weighting is you use the rating, but at the same time you use a number of votes. You would be doing the same thing, right? Do you buy the product only based on the rating, or do you also see how many people have rated the product? Do you see only one thing or both the things? I guess both, right? You see both the things. Yeah. So you will also see like, okay, how many people have voted for five? How many people have voted for one? Or and also like what is the average rating, right? And that is where this concept of weighted rating comes into picture. Yes, Shreyash, we can also use Power BI or Excel. The only limitation with Excel would be that since this data is extremely huge, so you might face a lot of challenges by loading in.
Does this project comes under like data science or ML?
As I mentioned, it's machine learning, right? It's machine learning, but not, I mean, machine learning ops. I think Akshay, you're getting confused between machine learning and machine learning operations. I'm assuming that that's what in your head is. Machine learning operations is all about productionalizing the models, right? Machine learning is about building the models.
So
So
this
this will
project
come
comes under.
this will come under machine learning along with data science. But if we were, productionizing this model, putting it in the cloud, building a container instance, then it would come under MLOps. But this will come under ML. But I think what you are more referring towards is MLOps.
And what's the use of this project? General use.
We talked about the usage from for the last 40 minutes. We did, right? So how the companies are using it? Basically, you can see, you can open your Amazon app. You will know the usage of this product. I hope it makes sense. Can we use the Jupyter? Yes, for sure, for sure. So now I will also show you the model which we talked about, the hybrid recommender. So basically, which uses both content and the collaborative. So it's using both the models, both the content and the collaborative. And alpha, as I mentioned, is a factor or like a weight, like how much weight you want to give to content and how much weight you want to give for collaborative. So for building a hybrid model, you need to use a specific package. So within Skykit, Skykit is like the overall module in Python for building machine learning models. And in Skykit, you have something called Surprise. And Surprise offers these specific models under content and collaborative. So that's something that we need to install separately. So that is what we are doing here. So just like building those modules, and so that if you want to access some specific features from this particular call Surprise, we would be able to do that, right? So it should be done in the next few minutes. So once you guys, if you guys use this notebook, you should be also like installing it. So if you see, like I did not install like a pandas or numpy because those packages are something which is by default present in Python. But in this case, Skykit or Surprise package is something which is not by default present, right? And that's why we need to like install it separately. So now from Surprise, we are calling the specific modules. So we need to prepare the data so that the model can be used. And that is what data set and reader is. And SVD stands for singular value decomposition. It's the way of building uh, the collaborative model. So if you see, the rating scale is between 1 to 5 because That was the rating scale. We have a rating scale between 1 to 5. So what it will try to understand is the patterns between the user and the product, right? And based on that patterns, it will try to recommend, right? So there are three things here: the user, the product, and rating. So rating is like the interaction between your user and product. So in any model, in any machine learning model, we basically divide our data into train and test, right? So that we can train our model on a majority of the portion and test the model performance on an unseen data set. So this is the data set which will not be seen by the model to recommend, but will be used to evaluate the model performance. And this test site simply means we are keeping 80% of data in the training and the remaining 20% in testing, right? And so SVD is the main model, which is the collaborative model. And if you see, we are fitting it on the training set. And once we have fitted it on the training set, we can simply test it using the test set and make predictions. So the predictions will basically calculate and take these scores for your recommendation. And we can also evaluate the model performance through something called RMSE. So RMSE stands for root mean square error. Lower this score, better the model. So if you see, the root mean square error is 1.35, which is quite low, and it basically is a sense of how much the model error is, right? So higher the score, bad is the model; lower the score, better is the model, right? But the most important part is that now you can combine this model with the content, and basically we can create something like an hybrid recommender. So what you see is that first we are picking up the popularity, the popularity model that we built, and we are sorting it, and we are keeping an weight of zero point 0.5. Now the best part of it is that if we give a specific product ID, so in the previous model, the same recommendations would have been given to everyone, right? But now with the usage of this model, we can basically provide a particular product ID, and it can recommend me five top products, right? So what it's simply doing is basically deriving the predictions, deriving all the popularity based predictions, and then calculating the hybrid score, right? Based on this alpha, which we defined as 0.5 of percent. So, so based on this, we can pass on any particular product ID, and it can recommend me the top five items. So for example, for this particular product ID, if someone is searching for this particular product ID, the model will also recommend something like this. Now, that's the beauty, is that if I change it to something else, right? So I will get a different recommendation for each of them, right? So it's that is where it becomes personalized. That is where it becomes one, and that is where it is using the actual history of the user, right? And how it is using is basically using this data, where it is trying to understand the interaction between the user and the product, right? So based on this interaction, it is trying to learn and then trying to recommend you, right? So this is how an AI model or an ML model tries to uplift from a basic rule-based approach. So you are able to, recommend things which is just not very uh, mass, which you do not want, which is simply not like a mass-oriented result, but something which is highly personalized, right? And obviously, we can tweak this model further. We can try to include more things here, but this is a very basic, I would say, implementation of an recommender model. But definitely, it should give you a good idea of how you can add and build an like a collaborative model for yourselves, right? And as I mentioned, a lot of movie recommendations, product recommendations, or in fact any other recommendations works in this context. So it will try to see two uh, crux of things. So one is the product, which is we define as the items. Another is the user. So basically in this class, intersection of the two dimensions, we try to get an idea like which users are liking which kind of products, and that is what the model is trying to learn overall. Yeah. So I hope again we'll sharing this notebook, but I hope you guys got a good idea of it, of how the model works. We are not using any pre-trained model here, Akshay, because as you see, like we trained the model here using the test data set. Sorry, the model using the test data set, but we are training the model here, right? So it's not like we have some pre-trained model and we are calling it. Okay, sorry for that. You should not ideally get that. And what is the purpose of Scikit-learn? Scikit-learn is a main, I would say, module which can give you access to a lot of machine learning things, right? So a lot of machine learning models are part of your Scikit-learn package. We can use Jupyter, definitely. I think I missed that. Yes, you can use this code for other Amazon products. So what you will require essentially is three things. First is the product ID, second is the user ID, and the third is the rating. If you have so any recommender model will generally require these three things, which is easy to get if you are working for that organization. You will have the customer ID, you will have the product ID, and you will have, let's say, the rating that particular product was given by the customer. Yeah, for sure. Arya, you can. Ashu, as I said, I think there will be a proper way of sharing these materials. I will try to ensure that it's basically circulated. But yes, they would be given. Don't worry. Along with the data, because I think both of them will be required. Yeah. But I hope everyone got some good idea uh, about what content and what collaborative filtering is. I'm just trying to read all the comments. Can you share this notebook? How to make content based? So as you said, like as I said, like the content based is more this part where we are using both the weighted formula, right? So where we are defining the alpha and we are giving rank to both the things. So that's where we are using the content based filtering. Yeah, cool. I think we crossed the time. I also have to jump for a meeting, guys. I know it was a 1 hour session, and but I hope we were able to give you a good idea of recommender models in this 1 hour. I hope you found it informative and interesting. I'm sure the idea would be, to just excite you guys to, read about these models. I would try applying these models and obviously, showcase in your LinkedIn projects or in your GitHub and so on and so forth. Yeah, cool. Thank you everyone for attending this session and giving your time. I wish you all the very best for your all the engagements that you're trying to do, right? And yeah, I'm sure that you guys would get all the materials, so you should not worry about it, right? So don't worry about that. Okay, perfect. Thank you, everyone. Take care, guys, and yeah, I hope everyone understood. Cool. Thank you.
Can we leave, sir?
Yeah, yeah. Please, please. I will